All right, welcome to 5.5 day 1. We're going to apply the remainder theorem and the factor theorem. We're actually going to do some pretty cool stuff with polynomials. I mean, it's kind of math nerdy, but I think it's cool. So today our goal is we're going to be able to divide polynomials, and then the answer, we're going to kind of relate the remainder theorem and the factor theorem in there as well. All right, so the good thing is we're going to attach this to some prior knowledge. So remember back in grade school when you learned how to do long division. So the first thing you did was you asked yourself, how many times does 7 go into this first number 6? And it doesn't. So then you had to see how many times does 7 go into the number 67. So you went over to the side of your paper and you multiplied by some numbers until you figured out which one wasn't too big but wasn't too small. So then you put the number, so 7 goes into 67 9 times, so you multiply 7 times 9 to get 63, and then we subtracted, and we get a 4. And we call that 4 on the bottom the remainder. And then we learned a little bit later in grade school to make that into a fraction. So we have 9, the remainder goes on top, we make a fraction bar, and the 7 goes on bottom. So this 4 goes there, and this 7 goes here. All right, and the cool thing is this is exactly the same way that you do polynomials. So it's the same process, okay? So just keep that in mind. Remember how you do this, and then when we get to the polynomials, hopefully it'll make a little bit more sense. All right, this is the formal language, so if you, really care or whatever, I think it's cool, but then again, I teach math. So this function, basically it just says the function is divided by another function, and it equals a new function, and then you have a remainder over the divisor. So it's just kind of a cool way to write a bunch of functions. All right, let's go ahead and look at number 1. I know it says example 2, but I deleted the other one. So this is example 1. All right, so first off, notice how I wrote this out. Notice where I put the y squared plus 1, y squared minus y plus 1. Notice it's on the outside. All right, and then notice where the y to the 4th plus 2y squared minus y plus 5 is. All right, y to the 4th. Where did this y to the 3rd come from? Remember that if something's missing, you have to have its placeholder. So y cubed has to have a placeholder. Sometimes it's easier to forget that. And then the 2y squared, then the negative y, and then the 5. So 4, 3, 2, 1, none. Okay, it has to be like that. Then, well, everything else basically kind of goes in the margin of your paper, so I'm just going to make a margin. So what you do is you take the first term underneath. So first term underneath is y to the 4th. You write that down. Divided by the first term outside is y squared. You write that down. You simplify. That tells you what you're going to put on top. Way easier than dividing, like we were doing, with the 7 and the 67. So we'll put the y squared on top. All right? Just like what we did in old school, we're going to take this times this. Except for, in this case, we're going to have to distribute. So I'm going to take y squared times y squared times negative y squared times 1. I'm going to write all 3 terms down here just like we did when we divide normally. So y to the 4th minus y cubed plus y squared. Just like I did before, I'm going to subtract. The only difference is I'm going to subtract 1, 2, 3 terms. So I have to change all 3 signs. The first set should always cancel out. If it doesn't cancel out, you did something wrong. The second one, 0 y cubed plus y cubed is 1y cubed. 2y squared minus y squared is 1y squared. Bring down the next term. Go back to your margin. So now we have y cubed is our new first term. Y squared is our same outside term. And we simplify, and we get y. So we put a positive y up here. Then we take what we just wrote down, only the y that we just wrote down, times y squared times negative y times 1. Only the y we just wrote down. So y times y squared is y cubed. Y times negative y is negative y squared. Y times 1 is positive y. And then you subtract. So you subtract the first term, the second term, and the third term. First set should cancel out. If it doesn't cancel out, you did something wrong. Add these together, you get 2y squared minus 2y. Bring down the next term. All right, and then we start over. We have a new first term. So now our new first term is 2y squared. So out to the side, we write down 2y squared. If we still use y squared out front, we reduce that and I get 2. So up here I put plus 2. So now I take the positive 2 and only the positive 2 times all 3 of these terms. So that gives me 2y squared minus 2y plus 2. Subtract the first, subtract the second, subtract the third. First set should always cancel out. If it doesn't cancel out, you did something wrong. This happens to cancel out also, which is nice of it. And here we have 3. This is our remainder. So we're going to go up here, we're going to write plus, we're going to put the remainder on top, we're going to put a fraction bar, and then all we do is we're just going to copy this down. Y squared minus y plus 1. And that's it. Looks kind of hard, but it actually wasn't too bad at all. So pretty cool. Alright, let's look at the next. Okay, so let's practice this guy. So first, you're going to put the x squared minus 3x minus 2 out in front. And I have 4x to the 4th. I'm missing the third. Missing the second. Then we have x to the first power. And then we have minus 4. Take my margin. Take the first term, divide it by the outside first. 4x squared. Write that on top. I always scoot over 1. Alright, now you're going to multiply 4x squared times these guys. So that'll be 4x to the 4th minus 12x cubed minus 8x squared. Subtract the first, subtract the second, subtract the third. First should always cancel out. So I have 12x cubed plus 8x squared. Bring down the 5x. New first term divided by outside term. Reduce. That's what goes up next. Take what you just wrote up there, the 12x, times the x squared, the negative 3, and the negative 2. So I'm going to have 12x to the 3rd minus 36x squared minus 24x. Subtract the first, subtract the second, subtract the third. First should always cancel out. So 44x squared plus 29x. Bring down the next term. The new first, 44x squared divided by x squared. The same old outside. Notice that x squared never changed. And then we do plus, oops, what does that equal? 44. So I do plus 44. Take 44 times all 3 of those terms, 44x squared. 44 times 3, 2, carry the 1. Negative 132x minus 88. Subtract the first, subtract the second, subtract the third. First should always cancel out. So that makes x, 1, carry the 1, 6, 161. That makes 84. So this is our remainder. So up here we put a plus sign. Put 161x plus 84. Make a big fraction bar and copy down what's outside. X squared minus 3x minus 2. And that's polynomial long division. Okay, we will work on synthetic division tomorrow, which there is a little bit easier way.